Alright, so our team is called Undefined, and we're doing the AP Calculus AB 2014 FRQ number 5. This is FRQ question number 5. It is a non-calculator question, and to answer this FRQ, you're going to need to look at this chart and use it to answer A, B, C, and D, and I'll be showing you how to do A right now. Alright, for part A, we're supposed to find the x-coordinate of each relative min of f of x on the interval -2 to 3. And to do that, we need to find where the slope goes from a negative to a positive, which looks like this. And to do that, we have to find the slope equals derivative of f of x. So we look on our chart, derivative of f of x, and the only place on this chart, on this area, where it goes negative to positive is right here, and that is at 1. So our answer is 1, and so our minimum at x equals 1 is when our relative min is there. Alright, so for part A you get 1 point, and that 1 point is for justifying your answer. And the common mistakes for part A is either not justifying or using the wrong portion of your chart because you didn't know that the slope is derivative of f of x.
Okay, so for part B, we're asked to explain why there must be a value c for -1 is less than c is less than 1, such that f double prime of c equals 0. So since it's sort of asking for this, finding this value where a derivative, or in this case the second derivative, is equal to 0, we know that we're going to want to do something with either mean value theorem or Rolle's theorem, and in this case it actually works for both. So first thing for both of those theorems is that you have to prove that f is both, or f prime is both differentiable and constant, because you're going to use f prime to get f double prime, which you'll see later when you look at the theorems. So you know that f is twice differentiable, it's given in the problem, so then because of that you know that f prime is also differentiable because it's twice, and you know that f prime is continuous because it is differentiable. So knowing that, then now you can apply the mean value theorem and Rolle's theorem. So the first step in the mean value theorem method is that you have to show that f prime of, since it's from -1 to 1, -1 of 1 minus f prime of -1 over 1 minus -1 equals 0, because it's like finding the slope of the secant of f prime of x to ensure that that there is a tangent line where the slope is 0. And so you go into the table and you can find that f prime of 1 is 0, and also f prime of -1 is 0. So you get 0 minus 0 over, and then 1 minus -1 is 2. That equals 0. So then you can say, therefore, by mean value theorem, there exists value c for -1 to c is less than 1 plus, or is less than c is less than 1, such that f double prime of c equals 0. I'm not going to write it out because it's right there. And then for Rolle's theorem, you're going to basically do the same idea, except that you don't have to do this whole equation here. You just by the fact that f prime of -1 is equal to 0 and f prime of 1 is equal to 0, then you know that there must exist a value between 1 and -1, a c value, where f double prime of c is equal to 0. So then you would write a statement using therefore by Rolle's theorem, and then it would go on, and you write basically what the question says. So yeah. So the points for this question are 1 point for correctly using the values of f prime of 1 and f prime of -1 and using either theorem, and the second point is for your reasoning and that fact that you used the correct theorem to go with your work. Some common mistakes with this question are not fully understanding the theorem, and so making the statement about the reasoning not correctly correlate with your work, and also not using the correct values for f prime of 1 and f the wrong row on that chart. And then key concepts used in this problem are the mean value theorem or Rolle's theorem, and also knowing that f prime is the derivative of f and f delta prime is the derivative of f prime.
Okay, so for part C, we're going to be finding h prime of 3, and we are given that h of x is equal to the natural log of f of x. And so we're going to want to differentiate this equation, which is going to be the definition of the derivative of the natural log, which is 1 over f of x. That's our inside times the chain rule, which is f prime of x. And since we're finding h prime of 3, we're going to want to use our table here. So we're going to be finding f of 3, which is over here, which is 7, and then f prime of 3, which is 1/2. So now we can just plug these into our equation. So h prime of 3 is equal to 1 over 7 times 1/2, which is equal to 1 over 14. And then common mistakes are people forgetting their chain rule, since we do have to take the chain rule since it's the natural log of the function, and that it is given in our problem. And so not doing that, that would be doing h prime of x is equal to 1 over 7. Okay, and for grading on part C, it'll be 2 points for finding h prime of x, knowing that this is it, right here, that it's 1 over f of x times f prime of x, and then there's one additional point for your actual answer, 1 over 14.
So part D asks us to evaluate the definite integral from -2 to 3, f prime g of x, g prime d of x. So the first thing you have to do is remember the fundamental theorem of calculus, which states that an integral undoes the antiderivative. So from there, we know that it is f of g of x, and the limits of integration are from 3 to -2. So then applying this, we know that it is f of g of 3 minus f of g of -2. And by looking at the chart that they gave us, we know that that g of 3, so we go to g of 3 is 1. So it's f of 1 minus f of g of -2. So g at -2 is -1. Okay. So now all you have to do is look at these on the chart. So f of 1, that's f of 1 is 2. So 2 minus f of -1, which is f of 8. And you get that your answer is -6. Okay, so for common mistakes, a common mistake is that the people or whoever's doing the problem doesn't remember to apply the fundamental theorem of calculus. So instead of going to this part, they just plug in the values, which is not right. So for points, you get 2 points for remembering the fundamental theorem of calculus. So that's this part that you apply. And then the whole problem is worth 3 points, and then the next point is just for the answer. So the -6 is +1. But you could also stop at 2 minus 8. So the +1, the 1 point could be for the -6 or 2 minus 8.
Alright, so I decided to add this little portion in because why not? This is a bloopers. We have a few bloopers, but I added only one video because I didn't want to waste all your guys' time. So you're gonna be watching Jordan just do a little mess up here, and it's gonna be funny. I mean, at least I thought it was funny. And I hope you guys love my handwriting. It's really hard to like write on this thing, but like you'll live with it. So here's the video.
Equal to 1 over 1. This is getting 1 over 7 times 1/2, which is I can't do it like this.
Bullshit.
I can't write.
You're doing so good.
This is like a third grader's handwriting.
Okay, just grab it and move it.
Look at my 1/2.
Just grab it and move it this way. Grab it and
I can't.
move it closer
You
to
need to
you.
okay.
Move it closer.
No,
Move it
just do it
closer.
again.
Alright, so this is the conclusion to our video. I would like to give credit to Zumwalt for allowing us to use his classroom and the lab next to his classroom. And I would like to thank Louis for assigning this assignment to us because it helped me and my teammates learn quite a bit about this FRQ and what we need to do and what the requirements are. And I'm hoping to learn a lot from the other FRQs that are going to be taught in class. So that's going to be nice. And I hope you guys really love this cat photo because it took me about a whole 20 seconds to find it, and I wanted to put the intro at the end of a cat photo, so that's what I did. And yep, that cat looks like it's gonna eat you. Lovely photo. Thank you guys for watching.